G'day and welcome back to the channel, all of you DIY motion simulator platform builders. This is tutorial part 3 of the Dr ADHD 4-degree of freedom motion sim platform build. So where we've come through there with our hole saw, guys, it's a little bit rough, okay? It's rough, it's shardy, it's sharp, it's cutty. All right, and the other end of my mid-frame here where it was cut in the shop, this needs to be cleaned up a little bit like I did with the other end. So I've grabbed a couple of files, my normal flat file with the half circle on one end, and then guys, a rat's tail file, or rather a round file, is really good for this type of work. Now ultimately there's going to be a grommet that goes in this to protect our wiring. I'm just going to use that round half noon file here, and I'm just going to do the very edge, inside end here. Okay, the other thing to get yourself, guys, is get some shop rags, all right? Needed to clean that WD-40 off. The good thing is that it's on primer, so it's not going to be able to go into the metal. Problem with using that on bare metal, guys, is it's going to compromise when we come to do the paint for our motion sim. We want to keep as much primer on as we can. Where we can, we're going to have to take some of it off where we weld, guys, because we need to take any primer, paint, rust or mill scale off before we weld, so we don't pollute our weld pool and we get a good strong weld. But we'll try and do it as minimum as we can. We want as much primer on for when we paint, so we don't have to add more primer. So it's a matter of keeping balance between removing what we need to get good strong welds, but not removing so much material that we end up having to, cost ourselves more money and put primer back on that we didn't need to take off in the first instance. So a shop rag, guys, a couple of shop rags is really handy for that sort of thing. Okay, guys, that's how we get that drilled and prepped. First thing that we're going to do is done, guys. Right, next step is we're going to put our new trolley rails on. So let's talk about what we're going to do with our trolley rails and how they are going to be placed on the mid-frame. So what we'll be doing, guys, is where we've drilled our hole in the top of our mid-frame, so our top frame sits on this hole, guys, we need to turn our piece around, right, and we're going to work in what is now essentially the front of our mid-frame, okay? We're going to roll it on its side, so then that hole comes to the side now, all right, because our trolley rails go on the side of our mid-frame. Our trolley rail material. This is a really heavy duty metal, guys, because we need this to be heavy duty so we have no deformation from our bearing roller carriage system that carries our mid-frame. So this is a very thick, heavy duty, 3mm in thickness, 40 by 40mm angle, okay? This is our trolley rail system, all right? This goes on the side of our mid-frame on both sides, opposite each other. So when it sits back the way it needs to sit, we have a trolley rail system, right, on both sides that take our bearing carriage. Now, what we need to do, guys, before we do anything else, we have some measurements obviously to do on our mid-frame to get these placed straight and exactly diagonal opposite one another. But first we need to clean all of this mill scale up off our angle, right? So when you get hot pressed metal that comes out of the smelter, when it's rolled out in the machines, you get this grey material, guys. This is called mill scale, all right? Now, even though we're not painting the trolley rails, because they will be just nice, clean, shiny metal, we need to get the mill scale off anyway, because it will end up in our bearings, all right, and it will mess with our bearings. So this is where we're going to use, to great effect, our sanding pad on our angle grinder, and we're going to take all of that mid-scale off. You don't need to worry about the underside, this side, guys, because you're never going to see it, all right? It's going to be welded on to the mid-frame like this, all right? And you'll never see that underside. So don't take time taking that off. It's not going to hurt. Being on the back side, it can break down all it likes, and it's not going to affect any of your paint. But on these sides where our bearings are going to roll, on our top of our triangle, guys, you need to take all that off carefully with a sanding pad, all right? Don't dig into this. Don't sit there on a sharp angle in the one spot for a long time. Don't want to remove. This needs to be true, okay? So very lightly with your sandpaper pad, we'll go over this and we'll remove the mill scale. I'm going to give you a demonstration how that's done now so that you can see how quick this is. This is not a job that's going to take you hours, and that's the beauty about getting the right tools for the right job. You get the right tools, guys, it will make this job very quick. If you try and do this with a wire brush or by hand, it's going to take you hours. Get a pad like this, it's going to blow your mind how fast this happens. So you are going to require 3 meters of the 40 by 40 by 3 mil thick angle. I recommend you go to your metal shop to pick this up. This is where the doctor went, and I got them to cut these for me in 3 1 meter lengths. You will be using full 1 meter lengths on the mid frame both sides, and then our actual trolley rail carriage system will be cut at 250 millimeters in length. All right, we'll cut that here in the workshop. We'll go through how to do that. But when you go to the metal shop, get yourself 3 lengths of 1 meter cut. All right, let's rip this mill scale off. I won't show the whole thing, guys. I'll just show how quick this can actually happen. And then the rest is rinse and repeat for all of your angle, all right? Round these corners, guys, while you're at it. So with the right tools, guys, that is how fast you can get that done, all right? What was that? 1 minute at the most, one side. So, you know, you're talking about a 5-minute job, 10-minute job at most for the whole 3 meters to get that ripped off with one of those sandpaper pads. Okay, so once you've got them cleaned up, and we need to have them cleaned up, right, as clean as a baby's bum, guys. Get all that mill scale off, get them nice and shiny. Now, obviously, where our trolley carriage runs on this with its bearings, it's going to probably track that in anyway a little bit, all right? But that's why we've gone with 3 mil steel, okay? Because this is coping with the weight of us, all of our sim peripherals, our top frame and everything. So that's why it needs to be the 3 mil thick angle, right? 40 millimeter by 40 millimeter, 3 mil thick angle. We need to measure our outside diameter here. And this is where it comes in handy, guys, as recommended, to go with a tech ruler, okay? If we put this tech ruler on, and if we look at our outside to outside diameter on this angle, it's 55 millimeters wide. We've got a 65 millimeter piece of box, all right? So what we're going to do is we're going to go over, I'm going to work out where to place our measurement on our mid-frame spine now. So then this sits on evenly on the box, and it should have a 5 millimeter gap each side on that box. So let's go and talk about how we set that up. So before we do this, just a reminder again, okay, that this is the top of our mid-frame where we've just drilled our wiring hole here at the back. That's the top of our mid-frame. Our uni joint will be on this. Our motor mount system will be on this. We're welding our new trolley rail system on each side like this, all right? That's how we're going. So we need to turn our mid-frame spine onto its side, right? We're going to get a measurement, guys. Now we know our mid-frame is 65. These are 55, right? So when we put these on, these are put on right flush, guys, with the front of the mid-frame. let me just bring this back. These will go flush right at the front of the mid-frame. Okay, the back of the mid-frame. So we've got quite a large gap at the back where there's no rails. All right. So these go flush. Our 1 metre in length, 40 by 40 by 2 mil, sit flush at the front of our mid-frame, on the side of our mid-frame. Okay, so I'm going to take this tool, guys, that I showed you earlier in my tool collection. This is something I built back in high school, right? So it's got like a flat edge here, that a little lock screw that's been put into this solid piece of 10 mil flat here with a scribe. It's just a nail scribe with a little screw that goes in the end that holds that nailing. You can make one of these. It's just made from a little bit of round that's been flattened on the end, okay? But you can buy these, so you don't need to make this, all right? I wouldn't suggest making this. Go out and buy one of these. This is just adjusted, all right? And that will give you basically a measurement on our box here for us to be able to set this up to scribe, right? So we've got a 65 millimeter wide box and we've got a 55 millimeter span on our angle. So I'm going to set this up, guys, to have a 5 millimeter gap between where my nail's going to scribe and where that's going to run along the edge. That's what I need to do. The best way to do this, guys, is with our tech ruler. Right, this tech ruler is 0 right at the end, so I can place that on like this and find my 5 millimeter mark. There we go. And then I'll lock that down. Then I'll double check it. What I'm going to do, guys, I'm going to set this up so then this will sit along the bottom of this line. Now these are a metre long, so we only need to go a metre. Remember, this is 1400 millimetres. So right from the start here, I'm just going to very gently scribe my line in along here. I'm angling my nail so it digs in. You can hear that digging in. I'm just going to do that from the front again because I didn't get a very good mark on the front. Rightio. I'm going to scribe in that line, 5 millimetres in on the bottom. All right, now I'm going to turn over. And then on this side, I'm going to turn this around like this so I can work this a little bit better. I'm going to do exactly the same. I'm just going to double check this first. Make sure nothing's moved. It hasn't. You can still see there we're at 5 mil. And from around this point here, we're going to do the same on the other side. So I just want to double check which side. Yep. So this is the bottom. Make sure it's on the bottom. There's our hole for the top. So make sure you're scribing along the bottom so it's the same as this side. So when we put these on, they're definitely lined up the same together. I have to go left-handed here, which makes me a little bit nervous. You've got to hold this steady when you do this, guys. There we go. Get that scribed in. That way we can sit our angle on that line. Right, so the bottom half of our angle where it contacts that line, that's where we're going to line this up. As I said, flush to the front of our mid-frame. We don't want these skewed when we weld them on, otherwise we're going to have a trolley roll system running downhill and uphill. No good. We're going to clamp this, guys, with some F-clamps. I'm going to show you those now. Another highly recommended tool for your arsenal for this build. You are going to need to get at least a set of 2 150 millimeter F-clamps or 200 millimeter F-clamps. You'll be doing quite a lot of clamping of metals when we weld, guys. When we weld, we have to have our metals clamped. Otherwise, they move when you weld. As soon as you start putting serious heat into metal, it warps, it moves. And we do a combination of clamping, tacking in multiple places, all right, before we do serious welding. I'm going to go through that with you right now. So, guys, we're going to begin the welding element of our 4-degree of freedom motion sim platform. This is the first thing that you will weld. And the good news for you guys is that the materials I've chosen to build this motion sim from are quite heavy duty, okay? Our mid-frame 65 by 65 box is 2.5 mil in thickness. And our angle we're about to weld on for our trolley rails is 3 millimeters thick, right? So it's going to be pretty hard, even for a beginner welder, to burn through this, all right? This is one good thing about this sim and what it's built out of. Not to say you can't burn through this metal if you just were to hold your welder on here and keep it on there. It can turn into a plasma cutter. You have to have movement and stuff like that. We're going to talk about that, but it's less likely and much easier for you to start with these sorts of materials than if you were to start with like a 1.6 millimeter or a 1 millimeter gauge material. You'd be burning through it all the time until you got your muscle memory sorted out and worked out how to weave and how to do good welds, all right? So this is going to be an advantage for you, not only the fact that it's a heavy duty industrial grade sim, it's going to be helpful for learning welding skills. So let's talk very quickly about our welder, and I'm going to have a recommendation here in the video of a welder I found on Fleabay or Amazon, Harbor Freight, whatever. It's a Chinese welder. I have a stick welder of the same brand. Okay, it's a Rossi brand. This is the little stick welder I've got. It's a 200 amp stick welder, inverter welder, little inverter chip. I've had this for many years. It's done a lot of hours, this Rossi brand, and it's brilliant. Okay, it's never skipped a beat, so I can, with confidence, recommend this MIG welder to you. So I do recommend, guys, you buy a MIG welder. It's going to be much easier for you to learn to weld with a MIG welder. Yes, it's more expensive than a stick welder, but there are many advantages of using a MIG welder. The main one being, guys, you have a large spool of wire. This is a 5 kilogram spool. It lasts many, many, many hours with welding. Unlike with a stick welder and the electrodes you use, you're changing the electrodes every 5 minutes. Electrodes on a stick welder, it's a bit harder to weld because you need to develop better muscle memory because you're really welding a long way away from where your weld pool is. And it's much easier to burn through metals with stick welders. Stick welders in general are used for heavier metals that need more penetration, okay? With a MIG welder, you can literally stay in one place because the wire feeds automatically as you weld. So it's much easier to build your muscle memory with a MIG welder, and you've got the advantage of not having to change out electrodes all the time. You have some maintenance you need to do with your MIG welder. You will frequently need to change your welding tips, okay, here on the front that your wire comes through. Because I use a gasless MIG wire, and that's what you will use a 0.8 millimeter spec gasless MIG wire. So this doesn't require gas, guys. It's like a flux core wire similar to an electrode, so you don't need gas. So you're going to save money on needing to buy or hire gas bottles. I'm just going to shut my door here just because my neighbour's kids are having a great time, but it's going to bleed through on the video. So no one's being murdered, guys. It's just my neighbour's kids having a good time next door. They're beautiful kids, but yeah, I'm sort of doing this at the same time as they're playing in their backyard. So yes, you will need to replace your tips a little bit more regularly because gasless welding is a little bit more violent than gas. So you will go through your tips more frequently, and you'll have issues where after maybe an hour of solid welding, your wire will end up fusing in your tip. We'll go through that, guys, and you'll need to replace your tip. So you'll need to buy a couple of sets, a couple of packets of 0.8 millimeter tips to go with your MIG. And this MIG, guys, that I recommend that you buy, the Rossi brand, I saw this on eBay for $199, all right? That is dirt cheap for a MIG welder. And on top of that, it has a detachable MIG hose, right? Normally, MIG welders in that price range, it'll be hardwired, okay? So if you have issues with your hose, if you have issues with your gun, etc., it's a real pain in the ass to have to replace that with a hardwired MIG hose. Like my Uni-MIG here, guys, if you have the money, by all means, you will not go wrong with a Uni-MIG. This is a 150 amp dual purpose MIG. This is a stick welder and a MIG. in one, but this is sort of over that $500 mark, right? So you're going to have to commit to more money. Admittedly, this will take a 5 kilo spool. This weld that I'm recommending to you guys, you'll only get a 1 kilo spool in it, but guys, for the money, it's got a detachable hose. It's a good welder for the money. So that's what I would recommend you buy. And they're the features to look for when you're looking for a MIG. Make sure you can change out your MIG hose and gun easily. And if you can find one, guys, that will take a 5 kilo spool, although it's a lot more money, you're going to pay 50 to 60 Australian dollars for a 5 kilo versus $20 for 1 kilo, right? But you can see where you're going to save money getting the bigger spool. Get the bigger spool. If you can find a welder that's in your price range, that'll take a 5 kilogram spool, has a detachable hose, you're sweet. Well, that is your lot for today. So until I see you in the next tutorial, you guys stay safe, stay healthy, and take it easy out there.